Hi everyone, this is Michelle, and I will be giving an overview of how to combat AP Calculus BC in my class. As a teacher who studied the rigorous IB diploma program in the American International School, our ultimate goal is to help you achieve the best results in your AP and school exams. So first, let's take a look at the test structure. The first section is your multiple choice question, and the second section is the free response questions, and these are the number of questions, the exam weighting, as well as timing. In this Calculus BC course, we will be covering over 10 topics, inclusive of limits and continuity, differentiation, contextual applications, analytical applications, integration and accumulation of change, differential equations, applications of integration, parametric equations, as well as infinite sequences and series, and many more. Next, these are the objectives for the FRQ, also known as the free response question. These are the exam weighting, and we will be doing a lot of practice involving how to implement mathematical processes, connecting representations, justification, as well as communication and notation. Moreover, our lesson will be goal-oriented by helping you to achieve the highest score in your Calculus BC exam. To achieve this, we will focus on intricate applications, long-word problems that most Korean students face difficulty in, as well as your weakest sections. So first, let's take a look at some example questions. The first key concept is how to construct and use Taylor polynomials. The coefficient of the nth degree term in a Taylor polynomial centered at x equals a for the function f can be defined as such. And utilizing this key concept, let's take a look at a question. Select the values of a function f, and its first three derivatives are indicated in the table above. What is the third degree Taylor polynomial for f about x equals 1? If this type of question is quite new to you, rest assured, because the goal of our class is to help you understand and gain confidence in how to approach this sort of questions. Next, let's take a look at some free response question. This is the first question. Let x be the region bounded by the graph of the polar curve in this equation for theta in between 0 and root pi, as shown in the figure above. Next, the question is, find the area of S and what is the average distance from the origin, which is 0, 0, to a point on a polar curve for the intervals of 0 to root pi. Simply, you have to take the integral of 0 to root pi and multiply that by 1 over 2. We're taking the square form of our theta, and the area of S would be 3.534. And for option B, after taking this equation, you're able to find out the average distance from the origin to a point on the curve is 1.580. To conclude, our process is very easy. Through the course content, you will gain knowledge and will focus on your individual area of weaknesses to finally result in your highest achievement. Thank you for listening, and find Michelle. I hope to see you guys in class.